Hello and good evening. My name is Muhammad Ali bin Muhammad and my message number is MA23048 and I am from Group 3. So today we will present about our project on the development of the Suzuki Swift 7 model 1.2 CVT for asphalt circuit racing application. So this is our group member consists of 5 person. So I will continue with introduction. So, motorsport is one of the most demanding areas in the automotive industry because the vehicles are required to operate under the high mechanical and thermal load while maintaining performance, reliability, and safety. Unlike race car, production vehicles are mainly designed for a daily transportation with emphasis on fuel economies, comfort, and reliabilities. Therefore, significant modifications are required before a standard vehicle can perform effectively on a racing circuit. In this project, the Suzuki Swift 7 model was modified to improve its performance, handling, safety, and overall sustainability for asphalt racing circuit. So, the Suzuki Swift 7 model was selected as the best vehicle for this project due to the several advantages. First, it has a lightweight construction with a curb weight of only 910 kg. A lighter vehicle provides a better acceleration, braking performance, and cornering capabilities. Second, the vehicle has a compact dimension which provide agile handling and quick directional response, especially on the technical racing circuit. Third, it is used a front-wheel drive or FWD layout, which offer a predictable handling characteristic and is easier to control during the aggressive driving. In addition, the Suzuki Swift is relatively affordable to purchase and modify, has a strongly aftermarket support, and has already proven its potential in track day event and amateur motorsport competition. Next slide is vehicle specification. The selected vehicles is a Suzuki Swift 7 Model 1.2 CVT. It is powered by 1.2-liter naturally aspirated 3-cylinder engine producing 82 horsepower and 108 Newton meter of torque. The vehicle uses a continuous variable transmission or CVT, which is designed mainly for a smooth operation and fuel economies. The curb weight is approximately 910 kilograms and the power is delivered through a front-wheel drive drivetrain. This specification provide a good lightweight perform for a circuit racing development. Next, I will continue for a body and chassis. So for stock body and chassis, before the modification, the Suzuki Swift 7th generation used a standard monocoque chassis without any modification motorsport reinforced. The vehicle has not equipped with a front strut tower brace or rear strut tower brace, so the body structure relied on the factory sport wheel only. Inside the vehicles, the standard driver seat and factory 3-point seat belt were retained. There was also no fire extinguisher installed. The rear passenger seat and sound installation material and full interior trim were still fit as a part of the original road car configuration. The vehicle has a curb weight of approximately 910 kg and a power to weight ratio of 90.1 horsepower per ton. Although the suitable for a daily driving, this setup is not ideal for a circuit racing due to the limited chassis rigidity, additional weight, and the reduced the driver support during the high-speed corner. So after the modification of the body and chassis, several modifications were carried out to improve the vehicle performance and the sustainability for a circuit racing. First, a front ultra racing strut tower and the rear ultra racing strut tower brace were installed to increase the chassis rigidity and improve the suspension stability. Chassis seam well reinforced was also added to reduce the flex and improve the structural stiffness. The standard driver seat was replaced with a Spectro Sprint FIA approved racing bucket seat, while an OMP 4-point racing harness was installed to improve the driver support and the safety. A fire extinguisher was also added as additional safety features. To reduce the vehicle weight, the rear seat, sound insulation material, and non-essential trim also was removed. As a result, the vehicle's weight was reduced from 910 kg to approximately 875 to 885 kg, while the power to weight ratio increased from 90.1 horsepower per ton to approximately 93 to 94 horsepower per ton. So as we can see, there is a before modification the body and chassis, and the picture of after modification of the body and chassis. So the modification provide several significant improvement. The installation of the strut tower brace and the seam well reinforced increase the chassis rigidity and reduce chassis flex during the cornering. This allow the suspension system to operate more effectively, resulting a sharper steering response and improve the cornering stability. The racing bucket seat and the 4-point harness improved the driver support, reduce the body movement, and allow more accurate steering, braking, and the throttle control. The addition of the fire extinguisher improved the vehicle safety during the motorsport activity. Weight reduction ac- of exp- approximately 25 to 35 kg improve the power to weight ratio and contribute to better acceleration performance, short, shorter braking distance, and improve overall handling. Overall, the modification successfully transformed the Suzuki Swift 7 model from a standard road car into a more capable and competitively asphalt racing vehicles for a bodies and chassis part.
So, good morning everyone. This slide shows the initial system before and after modification. The stock Suzuki Swift used factory ignition coils, standard nasal plug, factory ECU calibration, and a basic knob control system was suitable for daily driving. These components have a limitation during circuit racing, especially at high RPM. To improve performance, we upgrade the vehicle with high output ignition coils, NGK iridium, spark plug, ECU optimized ignition timing, and advanced knob monitoring. This modification provides a stronger spark, more efficient combustion, and better engine responsive during racing condition. The ignition system upgrade improved overall combustion efficiency and engine performance. The upgrade knob monitoring system also protect the engine from detonation, improving reliability during prolonged circuit racing session. The total estimate cost for the ignition system upgrade is RM3,230. The cooling system modification greatly improved temperature control. Overall, this modification improved overheating resistance, engine reliability, and performance consistency during circuit racing. This slide shows the lubrication system modification. To address this issue, we installed a buffer oil sump, oil catch can, fully synthetic performance oil, oil pressure gauge, and oil temperature gauge. This modification ensures stable lubrication under demanding racing conditions. The lubrication upgrade improved engine protection and reliability. The pressure and temperature gauge allow real-time monitoring, helping the driver detect lubrication problems before engine damage occurs.
Okay, Assalamualaikum and good evening. My name is Wan Muhammad Zafran bin Wan Zalani. My ID is MA22146. I will be presenting my part of this project. So first is transmissions for stock limitations. So starting with the transmissions, the stock Swift use a CVT, which is great, but great for fuel economy, but has real limitation on tracks. It has no discrete gear ratio, so the driver can select a specific gear for a corner. The belt and pulley system isn't designed for aggressive acceleration, and the open differential means the inside front wheel just spins under hard cornering instead of putting power down. Okay, next for transmission upgrades. So to fix this, we proposing 5 upgrades. First is the helical LSD is the centerpiece, because it sends torque to the wheel with more grip instead of the one that's spinning. So and then we pairing that with a heavy duty clutch and lightweight flywheel for sharper throttle response, and a short shifter for faster gear change, and polyurethane mounts to keep the whole drivetrain feeling solid under load. So next for the transmission cost summary. So altogether, the transmission upgrades come to about RM 7,550. So and the LSD is the most expensive single item, but it also the biggest performance gains. It's really what unlocks better corner exit speeds. Okay, so for the next part is suspension stock limitations. So moving to steering and suspension. The stock setup, McPherson struts up front, torsion bin at the rear, is comfort tuned, and that means soft spring and excessive body rolls in corners. And the rear geometry is fixed, so we can adjust the camber or toe back there, and the rubber bushing let the suspension flex more than we want under hard cornering and braking. Okay, next is suspension upgrades. So our upgrade plan covers 6 components. Adjustable coilover let us lower the ride height and tune the damping. Camber plates let us dial in negative camber up front. And we're adding front and rear anti-roll bars to control body roll. Polyurethane bushing to remove unwanted flex. Adjustable rear control arms for tow control, and upgraded wheel bearings to handle the higher cornering loads. Okay, for the alignment setup, here's our recommended alignment. Front camber at minus 2.5 degrees, rear at minus 1.5. And this negative camber compensates for the camber loss that happens during body roll, keeping the tires contact patch flatter on the road through the corner. And front toe is set slightly out for sharper turn in, and rear toe stays neutral for predictable behavior. Okay, next for suspension cost summary. The suspension upgrades total roughly RM 9,750 ringgit. And the most expensive of our 3 system, and the coilover alone are about half of that, but they're the foundation everything else builds on. Okay, for the next part, for my last part, is braking. So for braking stock limitations, and now the braking system, the Swift comes with rear drum brakes, which is the biggest issue, because drums fade fast under repeated hard braking, and the front single piston calipers don't clamp evenly, and the rubber brake lines expands under pressure and soften the pedal feel, and standard brake fluids risk vapor lock once it gets hot enough. So for braking upgrades, we're proposing 6 upgrades here. 4 piston up front caliper for even stronger clamping. Ventilated slotted rotors front and rear. And importantly, we converting the rear from drums to disc entirely. High performance pads that stay consistent up to about 700 degrees Celsius. Braided steel lines for a firmer pedal. High temperature DOT for fluid to resist vapor lock. And brake cooling duct to manage heat over a full session. So for the cost summary of braking, the total comes about RM 8,950 ringgit. The calipers are the biggest cost, but the rear disc conversion is arguably the most important change from a safety standpoint, because it's what stops the rear brakes from fading.
Next, I will explain the modification for wheel and tire system. Before modification, the Suzuki Swift used standard alloy wheel together with normal road tire. This setup is suitable for daily driving, but it's not ideal for track performance because the wheel width is higher and the tire tread is limited during the aggressive cornering. After modification, I propose using lightweight force wheel, which is NST RPF1 together with semi-clip tire, which is Nakang AR1. The main advantage of this upgrade is the reduction of unsprung mass. When wheel weight is reduced, the suspension can respond faster than maintain better tire contact with the road surface. At the same time, semi-slick tire provide a higher coefficient of friction which improves traction during acceleration, braking, and cornering. Overall, this modification improve vessel stability and allow better cornering performance during track driving. Now I will continue with the aerodynamic system modification. Before modification, the stock Suzuki Swift is designed mainly for fuel efficiently and daily road users. The underbody is exposed, which causes turbulent airflow, and at a high speed, the rear section can generate lift, making the vessel unstable. To solve this issue, I propose installing several aerodynamic components such as front splitter, side skirt, rear diffuser, rear spoiler, and brake cooling duct. The front splitter help reduce airflow under the front bumper and tread downforce. Side skirt help control airflow beneath the vessel, while the rear diffuse improve underbody airflow and reduce drag. As a result, a vessel gain better stability at high speed, improve cornering balance, and better braking performance. This modification is important because in motorsport, vessel stability at high speed direct affect lap time and driver confidence. Lastly, I will explain the ECU training and data logging system modification. Before modification, the factory ECU has limited turning capability because it is designed mainly for fuel economy and emission control. It also cannot support major performance modifications such as turbo charging and advanced engine steering. After modification, I propose replacing it with a standalone ECU, which is Haltech Elite 1500 together with a wideband oxygen sensor, additional engine sensor, and GPS data logging system. The standard alone ECU allow full control of important engine parameters such as fuel injection, ignition timing, and boost pressure. It also provides engine safety protection by monitoring oil pressure, temperature, and air fuel ratio during racing conditions. In addition, the data logic system record engine performance and track data, allowing the driver and team to analyze performance after each session. Overall, this modification improve engine performance, reliability, and help prevent engine failure during track use. So that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Shazwan bin Muhammad Sajam. My matric number is MA22152. So for this slide, on this slide, we compare the engine horsepower before and after the modification. The original Suzuki Swift produced around 82 horsepower. After upgrading the engine with a turbocharger, intercooler, performance exhaust system, and standalone ECU, the estimate output increased to approximately 150 horsepower. So this represents an increase of about 83%, which significantly improved the vehicle acceleration and overall performance on the racing circuit. So we move on to the comparison of torque output. So this graph shown the improvement in engine torque. The stock engine produced 108 Newton meter torque. After modification, the torque increased to approximately 220 Newton meter torque. Higher torque provide a stronger pulling power, faster acceleration when exiting corner, and better responsiveness throughout the entire RPM range, making the car much more competitive on the track. So we go to the vehicle weight reduction analysis. This slide represent the vehicle weight reduction. The original Suzuki Swift weighed approximately 910 kilograms. By removing unnecessary interior components such as the rear seat, sound insulation, and replacing some part with lightweight racing component, the weight output is reduced to about 880 kilograms. Although the reduction is only around 30 kilograms, but it improves the power to weight ratio, handling, braking efficiency, and overall agility of the vehicle. So we go to the top speed performance comparison. This graph compare the vehicle top speed. The standard Suzuki Swift has a top speed of approximately 165 km per hour. After the performance modification, the estimated top speed increased to around 210 km per hour. This improvement is achieved through increased engine power and better aerodynamic, including the installation of a front splitter, side skid, and a rear spoiler, which improve in stability and high speed. So we go to the cost cost estimation. So this slide summary the cost estimated cost of the complete modification package. The major expenses include the engine system, suspension and steering upgrade, braking system, ECU tuning, and telemetry system. The total estimated project cost is RM 71,700. Although the cost is relatively high, includes all major performance and safety upgrade required to transform the Suzuki Swift into reliable circuit racing vehicle. So for the last for this slide, in conclusion, this project successfully proposed a complete motorsport modification package for the Suzuki Swift. The modification increased the engine output to around 150 horsepower and 220 Newton meter per torque, while reducing the vehicle weight to approximately 880 kilograms and increase the top speed to about 210 kilometer per hour. So this upgrade improved the acceleration, handling, braking performance, chassis rigidity, and overall racing performance. Overall, this project demonstrated that the Suzuki Swift can be transformed into competitive, reliable, and practical circuit racing car. So that's all for me. Thank you.